So my array of 2 is 11. So now when does this condition fails? Now my array again gets incremented with 3 and 3. So when I come again, I equal to 3 and n equal to 3. So when I check the condition I less than low, what happens? 3 is less than the condition fails. Okay, so my loop gets breakdown. So now what did I do is, in the array of final position, final n value, I just added the lower elements 19, 13, and 11. The same thing I need to consider in case of higher position too. So what would be the case in higher? How will I assign the value? This would remain same as this. Only thing is, instead of I, you will be incrementing the j value. And would it be the lower array or would it be the higher array? Would be lower or higher?
Higher.
Higher. Okay. Okay. So are we good till now on the left array and the right array part? The same thing repeats on your other thing. Okay, this is the one which is taken care on your initial for loop. Okay, so now we're done with the lower part and the higher part remains same as this. Only thing is your value will be like different. Let me copy and then do here also. So now here is you're comparing with the higher. What is the high value now? Right minus mid. What is the higher value? So right is 5, mid is 2. So this will be 3. Okay. So now here every time when you compare j, 0 is less than, again you end up with 3. So every time you're going to add the array of 0, 1 and 2. And here instead of 19, you're going to fetch it from your higher element. Okay. So this would be j. So what would be the n value when it comes to j less than high? So whenever we are entering into this loop, right, will the n be still with left, or if he has gone into this loop and coming back, what would be the n position for you in this case?
It would be like what we left from 4.
Yeah, so based on your situation, the n value gets changed. Otherwise, it remains with 0. But right now, in your case, it will be 5 here, the value here, this would be 23, and this would be the 12. So now coming back to the situation where you have a criteria where both the cases are less than low and less than high. Okay. So where your lower element is also less than and the higher element is also less than my j situation. Okay. Okay. So how would I handle it inside? Any suggestions or how can I do? Because obviously I need to check every time my left array and right array, basically lower array and the higher array, only then I can progress. So how would I segregate in this loop when both the situation, both the arrays are coming into picture? So let's say my I is 0, okay, low is 3, j is 0, and high is 3 again. Yes, high is again 3. Okay. So now when I'm going into this condition, right? So if it is low, I always fetch the lower array. So lower of 0, and this would be higher of 0 to my first condition. So what is the first check I need to do? This is the third part, like in the diagram, if you see, like you concluded this left and you concluded this right. Now you're going to compare both together and do a while loop. So what I'm going to do is the lower element 11 and the lower element 5 is going to be compared together. And if they are lesser, I need to do a sorting again. If they are equivalent or something higher, then I need to do one operation. So how will I take care of that? So I'm going to basically compare the elements in my lower array and the higher array. So what would be the condition I need to take care in my if loop? Lower array and some condition lesser than or equal to my higher array element. What is the value I need to pass in? Is it I or is it j or is it a n or is it low or is it high? What should I pass for an array to fetch the data? Kiruban, Janaki, are you there?
Yeah, there. So I think it's.
So basically, I'm going to fetch the element from a lower array. So right now, the lower array holds the three data, which is 19, 13, and 11. So when I'm performing comparison between these two, I'm going to check the data only, right? So when I'm going to fetch the data, what would be the position here? Is it I or is it low? What should I pass within this array part? And I'm doing the check.
It's I.
Yeah. So we're going to pass the index position, basically the way which value you're going to fetch. The same way in higher, which one do I need to pass? Because I'm doing check on higher part is j. So do I need to pass j or I?
So both for the same array, right? I or j.
Sorry?
I, j both are 0. So
No, both are 0 only. But every time that gets incremented. Okay, we are using this reference only for this position, only for the lower element. That is what we did here, right? Only for lower positions we used I, and for higher positions we used j. So both values will remain same. You can use I also. But basically we created this reference only for the higher part, the right subarray. So in that case, here what do we need to pass? Is it good to go with j or I can still use I?
I can use j.
So basically, I'm fetching the element of lower element and the higher element. Since both are in 0 case, I'll get lower 0 and the higher 0. So lower 0 after sorting is done. Maybe if not sorted also, 19 and 5. So I'll get the condition. 19 is less than or equal to 5. Condition satisfies or fails. So there is a failure condition, right? I need to handle the lesser than or equal to, so which is basically greater than value. So my 19 is less than 5, condition fails. So when it comes to else, I also need to handle. So what is the element we are actually looking for? Final part is this. N is my thing where I'm going to add every element. So array of n is my final part. So what I'll do is array of n. If the condition satisfies, this array of n will hold the lower of I value. Okay, if the condition fails, which array should I need to hold? Higher of j, right? I need to put this in my k value, which is the sorted one. Like, are we clear till this now? So basically 19 less than 5. If the condition satisfies, my final array will hold the value of 19 in this place. Since 19 less than 5 is not satisfying, what will I hold here? 5. Because my final sorted array should have only 5 elements, not the any other thing. Because right now we are sorting on the index positions of first part. This is done. Are we good till this or any questions? Janaki, you there?
Oh, yes, Megha. Yeah.
So after assigning, I need to increment a value, right? Which one do I need to increment here?
It should be I.
Yeah, so I need to increment I in this case. And in this case, which element do I need to increment?
J.
Okay. So in both the places, after assigning, I incremented the relevant lower and higher thing. But this position, the final array position is not yet incremented. Do I need to increment within the if else or can I do it outside?
You can do it outside.
Outside, I'm going to increment my n position. Okay. So now let's come and do the calculation part. So now in my first case, lower of 0, which is holding 19, is less than or equal to 5 is condition false. So in my case, array of n is nothing but left is 0, which will hold the value of 5 right now in the first iteration. Now again n is getting incremented, again it goes to the while loop. Right now my the condition has been incremented for else part. So where the j is getting incremented by 1. So now when I come here back, my I position is still 0. And my lower position is still 3. My j position is incremented by 1. And my high position is 3. And my n is holding a value of 1. So now in array of 1, I need to insert a data. Okay. So now when I go again here, lower of I, which is 0, which is again 19, is less than or equal to higher of 1. Higher of 1 is 23. 19 is less than 23. Equal to 23. So now the condition is true or false. I'm not able to hear any one of you.
And this condition is true.
So in array of 1, what data would I need to insert? So now it goes into first if condition. So lower of 0, which is 19. So that gets incremented in my next place. Okay. Now my n is, now the I gets incremented, right? I is equal to 1. And again, lower and higher remains same. J is again 1. And n is again incremented by 1, which is 2 right now. So now I need to increment the I need to add the value of array of 2. So now I'm coming back, lower of I. So lower of I is 1. Lower of 1 is 13. Okay. So 13 is less than or equal to higher of j. So higher of j is again 23. So what is the condition here? Is it true or false?
Yeah, I think I'm missing this one.
Sorry?
Okay. Fine. Yeah, you can.
You're clear so far or you have any confusions?
Yeah, clear to now.
Okay. So now what did happen? 13 is less than 23. The condition is true. So which value gets incremented this time? I or j?
I, right?
So I gets incremented by 1. Okay. So now array of 2 is again with which value? 13. Are we correct?
Yeah, 13.
So now let me go again. So this time my I position is incremented with 2 and j is still with 1 and n position is incremented with 3. Okay. So now I equal to 2. So again I go here lower of 2. Do I have lower of 2 or not?
Yeah, we have 11.
So 11 is less than or equal to higher of 1. Higher of 1 is again 23. So the condition is true. So my array of 3 position gets added with 11. Okay. Now which value gets incremented again? I plus plus or j plus plus?
I plus plus.
I plus plus. But the I gets incremented with the value of 3. Okay. So j is still 1 and n is with position 4. So now again I come back and when I try to fetch lower of 3, do I have value here?
It's out of.
So what happens whenever I increment, when it comes to this while condition, I fail here. Because my I value is 3 and the lower position is already 3. So this condition fails, it comes out of loop. So then you will go into the next while loop where you will see that how my condition is getting satisfied. So whenever you come out of this loop, your criteria is over. So after that, whichever loop will satisfy, we will proceed with that. Okay, so till now, any questions like how exactly we are going to do the merge sort? Understood the basic idea on basically we are dividing the array, and after dividing the array, we are just comparing the index positions of both left array and right array. And for with first element, we are doing the comparison of next lower element. And then until the higher element is not satisfying with any of the lower elements, we are iterating the first left subarray. And then we are again going back to the right part. So we are giving preference to the left position, that is lower position. Post that it is done, we are going back to the right position and then we are doing it. So if you see in this loop, we are using multiple loops to just sort the data. So if you see, we are going with 2 for loops, which is O of n square. And then we are using a while loop. And in that, again, we are doing n number of iterations based on your array size, which is again O of n and not less than n. And again, if you see, this is again O of n, which is again O of n. So the time complexity is really higher in case of merge sort. Do you agree or you?
Yes, Megha.
So basically, it is nothing but O of n. And when do we go for log of n? You remember?
When you go for recursive something, right?
So basically, we are doing the recursive thing, right? So basically, when you're using the sort by merge type, you're finding the middle element, and then you're actually doing the iteration in the usual middle element which you had, right? This is only one time we are doing it. We didn't do the middle element in a different. We didn't calculate the middle value in a different part, right? Did you get my
Repeat the statement.
No. We did the merge only with the basic understanding of identifying the middle element with what we assigned as left, what we assigned as right, right? We didn't do a recursive so far. It was just
Yeah.
right? But if you do this iteration, you'll not get a sorted array immediately, right?
So this part we can do at the final step, right? So once we got the lower and
Yeah, exactly. This part is taken care in the final step. So before going to the final step, that is what I said, the right part and the left part, right? So how do we send this merge thing and how do we send the values over here? So in this case, right, whenever you use this merge thing, we are going to recursively call this sort by merge type, okay? Where we are going to call our data with 2 different middle elements, okay? So what is the first one? What are the 3 elements you're going to call here? Array, left position, and the right position. Now the left position was initialized with 0, right? Initially, and then the right was with 5. Now, when you do subarray, left and right subarray, in that case, my right position would be middle, right? It would be middle element, right? So when I divide my array into 2 parts, so the left position for this 19, 13, and 11 will be left with 0, and the right would be the 2, 0, 1, and 2, right? When I go for the right extreme starts with middle, and the extreme one which goes with the right part. So what I'm going to do is I'm going to recursively call 2 times the same function, but different left and right positions. So the array remains same. The first time your left was with 0. So I'm just going with the left. And then the final one would be the middle. So the left part of the array goes like this. Okay, so middle. And when I call the second time, I'm going to use the same array. And this time the left position starts from which part? The 5 is nothing but the entire list, the 5 is the middle part, right? So in my case, the left one would be middle thing. Do you agree? For the right array, the middle position would be the left position, right?
Yeah.
So I'm going to take with middle plus 1 because my middle is always with a lower thing. If I give 2, I will not get the right element. So I need to take a higher element of that. So I'm giving middle plus 1 and the right element would be the right part. Do you agree with this? I'm just doing a recursive part here based on the division which we have done. And this is the conquer part where we are calling the final where we are actually doing all the logic to achieve the final sorted list. So this would be the way we achieve our merge sort. So basically we divide our middle and then we call the same sort. Basically you're calling the same merge twice. Okay, one with the left and right with the middle position. Another one is middle and right. Okay, and then you're calling the merge part. So every time when you call this, your middle position gets changed. Do you agree? Like you got an idea about what we're doing here? Basically, middle element is getting changed every time on your recursion. So on recursion, you achieve a time complexity of dash. What is that?
We will achieve log, right? Like you see.
Yeah. So whenever we go with recursion, we go with log n, right?
Okay.
So now we are doing n iterations. So for every loop, whatever array size is, we are doing n iterations. So n, and then it is calling recursively. So what would be the time complexity in case of merge sort? N log n. Got an idea on why we are getting n log n. In all the cases, even if you go for best case or the worst case, we need to sort the entire array. There is no other option because we are using the divide and conquer strategy here. So anyway, your entire array has to be sorted explicitly till each element has to be sorted, right? So this will be n times, but every time it changes based on the array size. If it is 6, you will go for 3. So if it is 7 or 9 something, you are again dividing it, and all the division part has to be sorted again, and all the division part of your right array has to be sorted again, and then you have to conquer together to get the final sorted list. So every time you're going to do it recursively for n times on the divide and conquer method. So the merge sort would always end up with n log n. Any confusions or clarity you require here?
No, Shweta, nothing from me.
Okay, so are we good till in the merge sort part? So the complexity would always be O of n log n. This would be the time complexity in case of your merge sort implementation. So can we go ahead with the other sort, or we can see it tomorrow? Because I don't want to add everything today and get confused. So
We can see it tomorrow.
Can we see tomorrow?
Yeah, okay, fine. Yeah. So
Can
I
you share the code alone?
Yeah, sure.
The logic that you have built.
You can try with a different set of arrays and see whether this code is working fine. Okay. I mean, there might be worst cases. You can also try with different arrays with a higher set with odd numbers also, and see whether this logic is working fine. And try to print the final array. Like you can add one more for loop, and then you can print your sorted list, the array part, and then you see whether you are getting the merge sort properly. And you can let me know if there's any logic issues in the merge sort part. So we'll see tomorrow on the other sort. Basically, we might go with the heap sort, because for Java, we might go with heap sort and the quick sort also, because that is also the time complexity is better than the merge sort. So we'll try heap and quick tomorrow. Merge is basically a higher complexity, but it is easy to understand, but it takes time to achieve your result. That is the reason we never go for merge sort easily. We always prefer a less complexity one.
So that's it for the day, right?
Yeah, yeah. So you can try for different array and let me know if you have any issues on implementing it.
Yeah, sure.
Thank you. Have a good day.